Hello, in this video I'm going to present a prototype I created a few years back for a Kontakt instrument. The prototype's primary objective was to push the boundaries of expressiveness in virtual instruments by relying on a relatively limited amount of audio samples and, on the opposite, on an extensive use of scripting. My focus was on delivering the highest level of real-time control over dynamics and articulations. For the prototype, I specifically chose the saxophone, as I consider it to be perhaps the most expressive music instrument. And on top of that, the saxophone boasts a very high degree of timbral variety, which obviously adds an extra challenge while trying to create a high fidelity emulation with a limited number of audio samples. With this prototype, I really tried to achieve a highly realistic control over real-time dynamic changes, like having a complete control on crescendo and diminuendo on a single note, seamless transitions between different articulations, for example, having a sustained sound moving towards a growl within the same note, and also legato technology that could faithfully emulate rapid note transitions at any dynamic level. I recorded a saxophone in 5 different dynamics: pianissimissimo, piano, mezzo forte, fortissimissimo, and overblown. And I recorded the attacks separately from the sustained portions, as I wanted the instrument to have both tongued and untongued attacks. So the primary challenge of emulating the complete dynamic range of a note by mixing 2 samples from adjacent dynamics, like for example simulating a note between pianissimissimo and piano by mixing a pianissimissimo sample and a piano sample, is in the case of saxophone, is in the case of the saxophone attack, is root in how the sound is generated inside the instrument. The attack of a note is defined by 2 distinct events: the moment the player's breath impacts the reed, and the subsequent vibration of the reed itself, along with the resonation of the instrument's body. The time gap between these 2 events varies a lot with the dynamic level, because it's determined by the strength of the airflow entering the saxophone. For example, the difference, the delay between these 2 events, the airflow and the resonating and the resonance, is much longer in a pianissimissimo note than in a fortissimo note. And we can hear this with this example. We have here a C3 played in pianissimissimo, followed by the same note played in the piano. And we can tell how the body of the instrument starts resonating much later in the pianissimissimo sample compared to the piano sample. So this is the pianissimissimo. And this is the piano. You can really tell how in the pianissimissimo the sound of the airflow starts way earlier than the tonal component, which is the resonating body, to the point that you can clearly hear it without the resonating body for a few milliseconds. While in the case of the piano, in terms of time, they are already pretty much merged. Clearly, this difference in timing presents an issue when mixing samples from 2 different dynamics. to achieve a realistic emulated sound. These two events that define the attack, the sound of the player's breath and of the air that enters the reed and the instrument, and also the sound of the resonance of the instrument which starts resonating, must be synchronized separately. So what this prototype does is basically working on synchronizing these different components of the sound of the saxophone. So what we have in the Kontakt group, in the Kontakt instrument, is a group for every dynamic, which includes the tonal component, and a group for each dynamic, which include the noise component. This way, the Kontakt script can synchronize the tonal component and the noise component separately. Because as you can see here clearly, the time gap between the attack of the tonal component is much wider than the gap between the attack of the noise component. So all these parts must be worked out separately. And that's what the Kontakt instrument does. So if we take as example a note which is played halfway between pianissimo and piano, which means that the four audio files are mixed at an even volume. In the case of the tonal component, at the -6 decibel gain, -6 because these two audio files are phase line, which means that there's no either phasing or loss of power while they're playing synchronized together. And in the case of noise, obviously we are talking of -3 decibels each of gain. So what does the Kontakt instrument do? First thing, he reads some lookup tables where you can find data about the position of the peak of the attacks for each file. And by doing that, it can compute the timing in order to have the two tonal audio files attacks synchronized. This means that, as you can see, it takes much longer for the pianissimo file to start resonating than the piano file. So because of that, there must be a sequence determined by the script where all these four audio samples have been triggered in different timings. Now we carry on with this example, and as we are talking of a note which is exactly halfway in dynamics terms, is exactly halfway between the pianissimo and the piano, what we want to do is to make the note start exactly in between this time gap, between the beginning of the tonal pianissimo and the beginning of the tonal piano. If you were, instead of 50-50, if you were, say, 75% piano and 25% pianissimo, in this case, the T0, which is the very beginning of the note, the first trigger, would be here. So the playing sequence is at T0, the first triggering event, the Kontakt instrument, the script, is going to trigger the tonal and the noise audio files of pianissimissimo, which are, you know, the slower audio file, the one which takes longer to reach the peak. What it's going to do, the script is going to start reading the file with a little bit of offset, because this part, the part before the T0, is not going to be played. The file is going to start being playing from here, and the same applies for the noise audio file, where a very small, just a few milliseconds, is going to be skipped, and the reading of the file will start from this point. Then after a few milliseconds we will have T1, where the noise component of piano is going to be played, and you know, the timing is going to be calculated based on the fact that the two peaks must be synchronized. And again, after a few milliseconds, the final event is going to happen, which is the triggering of the piano tonal audio file, which starts here. But doing this, everything is going to be synchronized. Of course, the Kontakt script also is going to calculate the right timing according to the fact that the two tonal components must be phase aligned. And again, this is something that's going to do based on reading some lookup tables and calculating the right amount of delay in triggering all these different samples. So after this little introduction, we are going to move to the DAW and have a look at how the Kontakt instrument works. So here we have a single note which has been already recorded, and since the Kontakt instrument is different round robins, I had to pre-record them in order to find the right source files and put them, synchronize them in order to show how it works. So let's say that this is the beginning of the note on event. And again, we have a pianissimissimo. It's going to be mixed up with the piano. And as we can see, the first file which has been played is the tonal part of the pianissimo, which is here, followed by the noise part of the same file, and followed by the noise part of the piano, and the two files are supposed to be synchronized to have their peak, which is probably this one, synchronized. And after a few milliseconds, the piano tonal component is going to be triggered, and again the purpose is to have the attack, which is somewhere over here, synchronized. So now we're going to listen to the full dynamic range of the Kontakt instrument. It's going to be real time. Here we have the MIDI note, a ribattuto of the same note, and this is the dynamic range, which is controlled by a CCC, by MIDI CCC, not by the velocity, because the idea is to give a full control, a real-time control to the player, which can be achieved much better by CC MIDI control rather than by the note on velocity. And we are going to record it in the meantime. So let's start. I use auxiliary channels in order to track the different components. Here we have the proper full output with all the components blended together, and here we have the tonal components of either the overblow or mezzoforte or pianissimo, and here we have the tonal component of the fortissimo of the piano, and then we have the noise components here. Everything synchronized, and as you can tell, there's never the feeling that we are working with two different attacks. There are two different sound events going on. It's always a clear single attack, although obviously it's an emulated one. Thanks for watching.